So this is going to be a quick talk with some time for questions, and I hope I leave you with some high-level ideas on how to build production-level AI agents. I think it's no secret, everyone here, how people are working on agents right now in the audience? What are you other people doing? I think this is the time that agents move into production, and I think what we've seen over the last few years with Gen AI is Gen AI is easy to demo, hard to productionize. Software is always like this. ML was even more like this, but I think Gen AI has been just extremely easy to demo and very hard to get shipped. And I think actually agents is even yet another level of this. Like the amount of amazing demos that you see in Silicon Valley as an entrepreneur just blows your mind. And when we talk to customers about what do you really have running in production, it's shocking how little that there is. But I think it's coming, and I want to talk about what we've seen in getting people to production. How many people have used weights and biases? Any weights and bias users here? Awesome, appreciate it. I've run weights and biases for the last 8 years, and our mission has always been to build the best developer tools for AI. We've always felt like helping developers actually get their projects from demo into production, whatever that is, whether it's traditional AI, whether it's Gen AI or building agents, that's what we've always been about. And after 8 years, we're super proud that over 1,500 enterprises use weights and biases. And this is everyone from OpenAI and Meta building these foundation models to Canva and Salesforce, kind of exciting dynamic startups, to folks like AstraZeneca and Siemens and people that build really meaningful applications that help real people out in the world. It's super exciting to see how many places AI touches and how many applications we're able to support. I should say, these days we feel like we have 3 different types of developers that we're talking to. We have the foundation model builder. This is a small group of people that works on these huge distributed systems and try to build the LLMs that we all use now. And then we have the AI engineers that go in, maybe fine-tune, maybe tweak those models and try to make them work for real specific applications. But now, the biggest user of weights and biases is more like a traditional software developer that's hitting these APIs and doing that and doing useful things. And we love all 3 of these different developers that we work with to get things into production and working. The weights and biases platform, briefly, we have 2 real products. Models might be the one that you're familiar with. This is what people keep coming up to me and talking to me about today. So this will help you build a model, fine-tune it, do reinforcement learning. Weave is our newer product that helps people develop these AI applications. So it helps you observe them, see if they're working or not, improve them, which is really what you need to get them into production. I think something that everyone's learning now as they get into AI, it's been true for a long time, is that software development is this really linear process, mostly, right? Mostly you ship new features, you add functionality, maybe you have a bug, you go back and fix it, but most of the things that you do see the light of day. In AI development, you're building on top of a system that's non-deterministic. You don't necessarily know what it does, right? I mean, if you send something to GPT one day, it might give you the right answer. You might send it to the exact same model the next day. Behind the scenes, they're always improving these models. It might reverse course and not work, right? If you ask me, hey, Lukas, would this idea that I have, would it work? The answer is you don't know. You have to try it. And that's what makes AI development a much more experimental process than software development. And I think as software developers now move into these agentic projects, they're realizing this. One thing that happens when you have this experimental workflow is that your real IP here is not the code you write. With software development, the code that you write is really valuable IP, and no company in the last 20 years would not check this into some version control, would not care about their software, would not protect it. But in AI development, most of the things that you do are experiments that don't see the light of day. So whether or not you're doing a hyperparameter search on a fancy model or trying different tools and different prompts for your agentic systems, most of what you do doesn't actually work. It doesn't actually show up in the end product. And what that means is that along the way, it's the things that you learn that are really valuable. So if you don't write those things down that you learned, if you don't keep track of all the failed experiments that you try, your IP is walking out the door when you walk out the door. And I think executives are trying to realize this and trying to build systems to more accurately track what's going on. As I said, there's lots of different approaches. There's lots of different levels in maturity in AI, and that's totally fine. I think all the things I'm going to say today apply to whether you're completely new and trying to build kind of a simple system. Often these days it's like a chatbot, all the way to AI-focused, AI-native company that's where AI is completely core to what you're doing. It's definitely a new paradigm. I want to talk about two interesting projects that we did at Weights and Biases. Usually I use customer examples, but these days I think the weights and bias examples are maybe more interesting because I can really go into the details and tell you everything that we're doing. I promise that our customers actually follow almost identical patterns, but I can't get into the weeds as much with them as I can with these projects that we actually worked on ourselves. First of all is the weights and biases MCP server. How many people have worked with MCP? How common is that? Interesting, maybe less than I thought. I feel like MCP kind of became this hot thing that everyone's talking about. Maybe there's like a little bit of disappointment, and maybe now it's actually kind of starting to get into real production. I'll say weights and biases, MCP is core to what we do. What MCP is a way that applications can provide themselves as context to other LLMs. So MCP is a way that you don't have to build your own tools. Other people can turn your product into a tool that they can then use in their agentic workflows, including Claude or Cursor or OpenAI. So in a way, you don't have to build your own agents here for your software if you provide an MCP server to other third parties. And this has worked super well for us, right? So we built a weights and biases MCP server, and now instead of logging into weights and biases for the tasks that you want to do, you can go into Claude, you can do a one-line integration with our MCP server, and now instead of logging into our system, you can actually ask questions in natural text from the Claude system. And every time Claude releases a new model or a better model, this system will automatically improve, right? So it's meeting our customers where they are, and it's having customers interact with our product through agents. I find this super exciting. I actually use this every day. You can Claude will even build its own graphs, custom graphs, and data analysis on weights and biases data stored in our server. So this is super powerful for our customers because you can gain insights from experience using natural language, which you're all familiar with. And as this scales, I think observability in the decision-making process becomes really essential. Like, why did your agent decide to tell you to do something next? You really want tracking for that. So that's a big part of what we offer for MCP. I want to walk you through one more project that we did that was really interesting, which is a SWE-bench. Anybody know SWE-bench? How many folks are familiar with SWE-bench? A very small few. So I'll define what it is. So the SWE-bench data set is actually 500 instances of real-world GitHub instances on open source projects in different public repos. These are kind of hard coding challenges where you can actually tell if someone passed it or failed to do it. So this is a software engineering challenge. It's actually asking agentic systems to act like a software engineer. This is probably the best benchmark out there. Example problems, these are actually real things that if you're an engineer, you're probably doing today. So enable quiet mode such an overboost in Clee for using a pre-commit hook, right? With some details of what they want. The state of the art, this is less than 2 years ago, was solving 1.96% of these tasks. And folks published a paper on it. There's a big breakthrough in March 2024 when Devon got 13%, which is far better than anything had been seen before. And actually, they raised it a $2 billion valuation off a 13% success rate. It was pretty exciting. The competition heated up. I think there was Claude released Sonnet, OpenAI released GPT-4o. And we said, you know what? We want to see if we can build an agent here. What's that going to take? And we're going to learn stuff along the way about building agents on this really hard agentic challenge. So we picked O1. We tried the different models. That seemed to work the best for us, because for a number of different reasons, but it felt like it really followed our instructions. We found that each model needs slightly different prompt engineering. So I think depending on what your prompts are, you might find that different models would have different success rates. But I think our engineers really liked it because it would actually do what we said, which is actually surprisingly hard to get LLMs to do that consistently. We really thought about outcome-oriented prompting, so we put lots and lots of detail in our prompts to tell it exactly how we wanted it to approach the problem. And then what did we improve? So what happened here, right? So we wrote a prompt, we built an agent that used O1 to answer SWE-bench questions. There's you can think about okay, what tools should I give it access to? How should it edit my code files? What should I tell it to do? Should I tell it to do test-driven development or not? All these things. I think the secret sauce, which I'll just openly share with you, the reason I think we did this well was a really fast experiment loop, right? So we were able to set up a system to run experiments really, really fast. And every weights and biases customer at scale this is the thing they care about, right? It's the time to do an experiment. I think that's a unit of time as you're trying to ship agents, right? Because you're gonna need to do a lot of experiments before you get your agent to a necessary quality to put into production. And then you're prioritizing what to try. We thought a lot about this. We built tools to kind of run things quickly and analyze them. We improved these tools over time, and we learned that you gotta make it easy to look at actual examples. So where did this fail, right? There's 500 examples. Every time you run it, you wanna see, okay, where did this get confused? People keep asking about hallucinations. Hallucinations always show up. It's kind of how do you deal with them? How do you know that the system's hallucinating? And over 2 months, we got this agent working well. We spent hours debugging it. We built new tools for it. We also continuously implemented on prompt engineering. And I think one important thing that's probably not talked about enough is counterfactuals, right? So, when a system breaks in a whole set of tool calls, you want to go back and look at that moment where your agent went haywire and see, okay, would this happen 1 time out of 100 or would it happen 100 times out of 100? Those are super different, right? You might have gotten unlucky because your non-deterministic system went down the wrong path, or there may be something fundamental where it's always going to go down the wrong path. So we kind of kept trying, kind of injecting new ideas in the middle of an agentic process and seeing what would happen. We were super excited. We got first place on the SWE-bench leaderboard. So this is 64.6% of the issues. I think we stayed up there for about a month while other folks iterated and passed us. I think one awesome thing about SWE-bench is you have to publish all the stuff that you do to get on SWE-bench. So there's a really rich feedback actually across different teams of improving these systems. I think state of the art is now around 80%, which is, I think, better than human accuracy. Even a really strong programmer, I think, struggles to get to that level. So that's like one kind of quick example, but that really looks like every customer that we have that really has things in production. I would say the basic lesson for anyone trying to build agentic-powered apps is to start with a prototype, spend a lot of time building an evaluation framework, and then iterate. And if it's possible to incorporate user feedback, that's really powerful because your evals are never going to match what users are going to really do in production. So kind of being able to iterate quickly on simple things fast, and then being able to put something into production and get feedback from your production users, if possible, is really the key to success. So again, we started with layer prototype, we built this framework, we incorporated end user feedback, and iterated. So we have a product, Weave, that also helps with some parts of this. It's about evaluation and monitoring. You can plug it in to work with your RAG or fine-tuning or agents, or whatever that is, and evaluate new agents, monitor things in production. And I think another key here is with like any tool in AI right now, if you want to make a successful tool, you have to make it super easy to get started, right? There's so many different things you could try. Shortening that iteration time, that integration time, is kind of key for anyone to be willing to try anything. So I do think it's kind of exciting to take a step back, and I just always want to do this in talks I give now and kind of wonder at how amazing it is to be in AI in June 2025. I think this knowledge is like unevenly distributed. But I've been doing AI companies since 2005. But even going back to 2020, right? This is 5 years ago. I don't know if people remember when this avocado armchair came out. Like this just like amazes me that this was like state of the art not very long ago. And if you look at do you remember image recognition systems getting confused like this between like dogs and chicken nuggets, or like dogs and and muffins? I mean, it's amazing that we've come so far that this just seems like silly. I was vibe coding with my daughter, who's 5 years old, and now she can actually like program games. So coming out of the SWE-bench thing, we can let this. And here we used Claude code for this. She can actually like build this game through a voice interface with the computer and basically build a working, like interesting game. I think people do not like realize how far this has come. It doesn't work every time, but she was actually able to build this awesome game. So I'm super convinced that what's happening right now is going to have this massive impact on humanity. I'm totally convinced that this moment right now is something that we're going to be telling our grandkids about. So we have a booth here, and we're giving. You're talking to folks in kind of a developer meetup. I think everyone that I talk to feels like a little nervous that they don't know everything that's going on. I actually think nobody out there knows everything that's going on. Like nobody knows what all these acronyms mean. But I think the key here is to stay like interested and make real projects work. Thank you so much. It's great to be here at Dev Day and talk to all of you.